Energy. Energy. It is defined as the capacity to do work. The capacity of an agent to do work is known as its energy, and it is measured with the units of work known as joule. The unit of energy is joule. Energy exists in different forms. Mechanical energy. It is of two forms: potential energy and kinetic energy. Heat, light, sound, electrical energy, chemical energy, nuclear energy. Like this, energy is in different forms: mechanical energy, heat energy, light energy, sound, electrical, chemical, and nuclear. And mechanical energy is of two forms: potential energy and kinetic energy. Energy is the cause and work is the effect. When a body is having when a source is having certain energy, it can do work. So it is the cause of work is the energy. Whenever a source is having the capacity to do work, then only work will be done. So work is the effect and the cause of it is the energy. Examples for potential energy. Examples for the bodies possessing potential energy. A potential energy is possessed by the bodies. One is elevated mass, wound spring, elongated spring, twisted rubber, etc. If a mass is lifted to a certain height, then it possesses energy. It is called potential energy. If a spring is wound, then the wound spring possesses energy. That energy is known as potential energy of the spring. If the spring is elongated, then also it possesses energy. That energy is also known as potential energy. If a rubber is twisted, the twisted rubber will have energy. That is also potential energy. So the bodies which possess potential energy are elevated mass, wound spring, elongated spring, twisted rubber. These are only some examples. Relation for potential energy of an elevated body. Relation for potential energy of an elevated body. Suppose a mass m is on the ground. Suppose a mass m is on the ground. It can be lifted up. While lifting up, if we apply the force equal to gravitational force, then the body moves up with uniform velocity. The body moves up with uniform velocity. In such a case, if the body is moved up with a force equal to the weight of the body, then the upward force applied will be equal to mg. And if the body is lifted to a height h, then the displacement is equal to h. We know work done is equal to F bar dot S bar. F bar dot S bar. Hence W is equal to mg bar dot h bar. Force is mg bar and h is displacement mg bar dot h bar. The angle between the force applied and the displacement is 0, since both are situated in the upward direction. Hence cos 0 is 1. So work done will be equal to mgh. Gravitational potential energy. Just now we have derived the relation for potential energy, which is P is equal to mgh. P is equal to mgh. Potential energy is actually the change in energy, the change in potential energy. That means if a body is moved up to a height h, then the change in potential energy is mgh. So from original position to the next position, the change in energy is mgh. We should not understand it as though the initial energy is 0 and final energy is mgh. Whatever may be the initial energy and the final energy will be mgh more than the initial energy. Like this we have to understand. Hence we write the potential energy as a function of height. So UH represents the potential energy with height is a function of h, that is equal to mgh. This can be shown that the gravitational force is the negative derivative of the potential energy function. Gravitational force is the negative of the derivative of the function of height. F is equal to minus of d by dh of UH. Mathematically it is written as F is equal to minus of d by dh of UH. D by dh of UH is mgh. So d by dh of h is 1. Hence it becomes minus mg. obtaining potential energy from the relation between force and potential energy. The relation between force and potential energy is Fx is equal to minus du by dx. Fx is force is a function of displacement and du by dx is the derivative of energy with respect to displacement. By rearranging this, we will get Fx dx is equal to minus du, and an integration between two positions x1 and x2, we will get integral Fx dx under the limits x1 to x2 is equal to minus of integral du, and initial energy is ui and final energy is uf. On evaluation, you will get this as ui minus uf. Ui represents the potential energy at the displacement x at the position x, and uf represents the potential energy at the position x2. So the work done by the force is equal to, or the potential energy between the two positions is ui minus uf. This is the change in potential energy. Hence we can derive the change in potential energy from the function of force. Kinetic energy. Kinetic energy is possessed by a moving body. Kinetic energy is possessed by a moving body like flying bullet, flying bird, flowing water, blowing air, etc. Relation for kinetic energy. You have already studied the relation for kinetic energy as half mv square. Now let us try to derive the relation. First let us derive the relation for acceleration of a body which is having certain velocity. Suppose a bullet of mass small m is moving with a velocity v, and it enters a wooden block and travels through a distance x before it comes to rest. Consider in the figure the left side circle as a bullet of mass small m, velocity v, and suppose it enters the block and travels through a distance x before its velocity becomes 0. Then in our usual notation, initial velocity u is equal to v, final velocity v is equal to 0, displacement s is equal to x. U is equal to v, v is equal to 0, s is equal to x. And taking the relation v square minus u square is equal to 2as, v square minus u square is equal to 2as, we get 0 square minus v square is equal to 2ax. 0 square minus v square is equal to 2ax. From this relation, acceleration a is equal to minus v square by 2x. Minus v square by 2x. This is that means the bullet experiences a retardation. The bullet experiences a retardation while moving into the block. Now the relation for acceleration is minus v square by 2x. Force is equal to F is equal to ma. So that a is equal to minus v square by 2x. So it becomes m into minus v square by 2x. M into minus v square by 2x, or minus mv square by 2x. This is the force offered by the block to the bullet. This is the force offered by the block. So this is the force applied by the block on the bullet. The force applied by the bullet on the block will be equal and opposite. Hence, the force applied by the bullet is equal to mv square by 2x. mv square by 2x. Work done is equal to F bar dot x bar, F bar dot s bar. Here F is equal to mv square by 2x, s is equal to x. Hence, mv square by 2x into x, that is equal to half mv square. This is the work done by the bullet before it comes to rest. So that is its capacity to do work. Hence, it is known as its kinetic energy. Hence, the relation for kinetic energy is equal to half mv square. Half mv square.